Assalamualaikum and hi. So in this video, we are going to enter a new subtopic 5.4, energy stored in inductor. There are one learning objective here, which is to derive and use the energy stored in an inductor. U is equals to half Li square. So inductor is known as a device that can store energy in terms of ataupun in the form of magnetic field, and this is the symbol of inductor in our circuit. Okay, however, here we have two function of an inductor. The first one is to control the current that is going to pass through here, and also to store energy in the form of magnetic field. So the inductor here is going to store energy in the form of magnetic field. So basically dia akan store magnetic field lah. And in our previous video, we have looked at self-inductance, where it is a self-induction, which is a process of inducing EMF on the circuit by itself. Okay, so in that particular subtopic, we have also deduced the equation for inductance, where inductance L is equals to the ratio of the induced EMF to the rate change of the current. Inductance also equals to N flux over I. So these are the equation that we have deduced for inductance. Okay, consider an inductor of inductance L. Suppose that the time T, the current in the inductor is in the process of building up to its steady value I at a rate of di over dt. Okay, lagi sekali Suppose that at a time T, the current in the inductor is in the process of building up to its steady value of I at the rate of di over dt. Okay, so current dalam inductor ini dalam proses to go back to its steady value at the rate of di over dt. Using the magnitude of back EMF, EMF is equals to L di over dt. Induced EMF ataupun back EMF is given as L darab dengan di over dt dekat sini. The electric power P in overcoming the back EMF in the circuit is given by, so the power to overcome the back EMF is actually power is equals to I multiply with EMF. Basically dia adalah P is equals to IV lah. V kan voltage. So dalam kes kita, voltage ini adalah daripada EMF kita. So we use I, EMF, and EMF pula sama dengan L di over dt. So you're going to substitute this into, and you're going to get a new equation, which is P is equals to Li di over dt. Di over dt, dan L ni comes from the EMF kita. And then you bring the dt to the left hand side. You will get P dt is equals to Li di, and P dt adalah du. Power darab dengan masa, rate of change of the time, okay, akan give you energy. Sebab kita ada general equation iaitu E, energy, total energy is power multiply with the time dekat sini. So kita ada change in the energy with respect to change in the time here. So kita dapatlah P darab dengan dt sama dengan du. So du is equals to Li di. So the total energy stored in an inductor U as the current increases from 0 to I can be found by integrating the equation above. So dalam proses current kita increase daripada kosong ke I, the energy that is going to be stored in an inductor iaitu U can be deduced from the integration by integrating this equation. So kita integrate kiri dan kanan from 0 to whatever energy kita akan store, dan juga from 0 to whatever current yang kita akan ada. So after your integration, you are going to get U is equals to half Li square. U adalah energy, half L dekat sini adalah inductance, I dekat sini adalah the current squared. So for a long air core solenoid, so untuk solenoid, the self-inductance is, ini kita dah derive dalam video yang sebelum ni, iaitu L is equals to mu naught N square A over the length. Therefore, energy dia akan jadi energy for a solenoid. Okay, energy stored in a solenoid akan sama dengan half. Tempat L kita substitute mu naught N square, which is the inductance of the solenoid, darab dengan I square. You will end up with half mu naught N square A I square bahagi dengan the length of the solenoid. Okay, ini adalah length of the solenoid. So this is the equation for energy stored in a solenoid. So kalau dia minta energy stored in the coil, circular coil. So circular coil, the inductance is mu naught N square A over 2R. So energy stored in a circular coil akan sama dengan half. Tempat L tu kita substitute dengan mu naught N A, iaitu inductance of the circular coil. And then kita darab dengan I square. Okay, so the general equation is U is equals to half Li square. However, you must know how to derive. So you start the equation, kita start daripada power is equals to I darab dengan voltage kita, iaitu EMF dekat sini. You start from this equation.